Today I will explain you how cancer drugs are being named so that you can better understand the treatment strategy behind of each cancer drug. Coming up. Hi, my name is Ayguen Sahin from Cancer Education and Research Institute, formerly known as Cancer Research Simplified. Today I will explain you how cancer drugs are being named in a very simplified way. I teach this and many more tips to better understand cancer to everyone who comes to our cancer lectures and seminars. So I thought I would share with you this very simple but very powerful tip as well. Why? Because we believe that knowledge is power and the key for successful and timely cancer treatment. Also, this video will serve as an intro video, if you will, for the next video that we're going to publish about all cancer drugs that were approved by the FDA in 2016. We have that particular list on our website already published. You are welcome to read that article on our website at cancer@institute.org. It's again cancer@institute.org. I know you can't wait to learn about this great information, but before we get started, I would like you to please thumbs up this video so that everyone can see this and everyone can benefit from it. So let's get started. First, let's start with cancer immunotherapy drugs. How do we know if a cancer drug is a cancer immunotherapy drug? It's actually very simple. So let me give you an example. Let's start ahead with Opdivo, nivolumab. Opdivo. Opdivo is the trade name. This drug is called nivolumab. Nivolumab. I would like you to focus on the ending of this name. So, nivolumab is ending with a mab. This means that this drug is a monoclonal antibody. In terms of cancer treatment, monoclonal antibodies can bind to a specific protein or antigen and thus can activate the immune response against a cancer cell. Nivolumab is a monoclonal antibody that is targeting PD-1 protein. The PD-1 protein, as we call it, is a checkpoint inhibitor. A checkpoint inhibitor inhibits T cells or the immune system cells to attack tumor cells. When we block this PD-1 protein or the checkpoint inhibitors, we are enabling immune system cells or cytotoxic T cells to attack tumor cells and kill them. Another example is Yervoy. Yervoy. Yervoy is the trade name. Yervoy is called ipilimumab. Ipilimumab. I would like you to one more time focus on the ending. We just have learned, does it end with a mab? Yes, it does. It ends with a mab, so it is a monoclonal antibody. This means it's also, like Opdivo, a cancer immunotherapy drug. Ipilimumab is directed towards another checkpoint inhibitor, which is called CTLA-4. CTLA-4 is also a checkpoint inhibitor. We just have learned what happens when we block a checkpoint inhibitor. We are enabling immune system cells or cytotoxic T cells to attack tumor cells and kill them. By the way, a study that was published in 2015 in a journal called New England Journal of Medicine showed that ipilimumab and nivolumab was successful in a complete eradication of an advanced melanoma tumor compared to ipilimumab alone. And if you would like to learn more about melanoma, I encourage you to watch our very first episode called Cancer Types and find more information about melanoma there. You can also watch our sun protection videos. We have 2 videos about sun protection and skin cancer, and we are listing several skin cancer types there as well. Are all cancer drugs immunotherapy drugs? No, of course not, because other cancer therapy drugs can target specific tumor proteins or they can target specific genes. Let me give you the example of Rubraca. Rubraca is the trade name. Rubraca is called rucaparib. Rucaparib. Rubraca was recently, in 2016, approved to treat advanced ovarian cancer. We have a specific video for that, so I encourage you to watch that video. Rucaparib is targeting the BRCA genes. BRCA1 and 2 genes. I highly encourage you to watch also our ovarian cancer video so that you can understand the correlation between BRCA genes and breast cancer, colon cancer, and ovarian cancer. So rucaparib is targeting the BRCA genes. And also, as you can see, it does not end with a MUP. It's not a monoclonal antibody. So it's a specific cancer drug that targets a specific gene or specific genes. Another example for this is Tarceva. Tarceva. Again, this is a trade name. Tarceva is called erlotinib. Erlotinib. So does this end with a MUP? No, it doesn't. So it is not a cancer immunotherapy drug. However, erlotinib targets a specific mutant or abnormal protein which is called EGFR, a mutant version of EGFR protein that is expressed by cancer cells. EGFR means epidermal growth factor receptor. So when you inhibit EGFR, the mutant version of EGFR that is expressed by tumor cells, you are inhibiting tumors to grow, or you can slow down the tumor growth. So just to recap, I put together the information that we just have discussed here in a simple table so that you can hopefully better understand the mechanism behind of your cancer drug. As you can see here, when we see the ending, the suffix MUP, this means that this particular cancer drug is a monoclonal antibody. So it is a cancer immunotherapy drug. As we discussed before, I gave you an example of PD-1 inhibitor, which was a checkpoint inhibitor, if you remember. And then also I gave you the example of CTLA-4, which was also a checkpoint inhibitor. So nivolumab and ipilimumab are these checkpoint inhibitor blockers. Then I gave you the example of rucaparib, right? Rucaparib, when we look at rucaparib, at the ending, the suffix is parib. These drugs that end with parib are PARP inhibitors. They can inhibit, as we discussed before, abnormal BRCA genes. With PARP inhibitors, we disable DNA to repair itself. Naturally, our cells have a DNA repair mechanism. When genes become abnormal, then naturally our DNA repairs itself. However, when we inhibit this DNA repair mechanism with PARP inhibitors, we are disabling tumors to grow. Another example I gave you was erlotinib, right? Erlotinib was directed against a mutant version of EGFR. When we look at erlotinib, it has an ending of tinib. So all cancer drugs that ends with tinib are tyrosine kinases. Tyrosine kinases can be EGF receptor, and the receptors also for FGF, PDGF, VEGF. So these, as you can see, they're all are GF. What does that mean? These are all growth factors. these are involved in cell growth. These receptors for all of these growth factors, when these suddenly became abnormal, then it is so as if a on switch is constantly on, it's not being turned off. This means that a cell suddenly has a constant signal to grow. So they grow uncontrolled, and therefore when we block these tyrosine kinases with such cancer drugs, then we simply turn off this signal. We are disabling tumors to grow. Another example of such tyrosine kinase inhibitors is lenvatinib, which is directed against VEGFR1, VEGFR2, VEGFR3. So there are 3 growth factor receptors for the protein which is called vascular endothelial growth factor. This growth factor VEGF, as well as its receptor VEGFR, are majorly involved in development of blood vessels so that tumors receive their nutrition by these blood vessels. When we inhibit the growth of such blood vessels, we are literally blocking the development of blood vessels and the supply of nutrition to the tumor. So therefore, we are stopping tumors to grow further. I also included here antiviral drugs. When we see a drug is ending with vir, this means that it is an antiviral drug. Here, I give you an example of sofosbuvir, which is a drug to treat hepatitis C virus. And another example is adefovir, which is a drug against hepatitis B virus. So I hope you find this helpful. Thanks for watching. And if you like this video, please give us a thumbs up and share this with your friends and family. We want everyone to understand and learn about how cancer drugs are being named so that you can better understand the strategy behind of each cancer drug. If you would like to donate to our cancer education nonprofit organization, you can do so securely through our PayPal page on our website at cancer@institute.org/donate. If you would like to read more cancer articles, you can find those on our website. If you would like to have more cancer information and resources and more updates about what we are doing, I encourage you to sign up for our free e-newsletter, also on our website. And if you have any comments, questions, or anything you would like to share, comment down below in the comment box. We would love to interact with you. And if you have more specific questions that require much more deeper information specific to your disease or your particular situation, and I encourage you to visit our website and go to our patient platform page, and you can send us your question confidentially. So thanks again for watching, and I'll see you in the next episode. Take care.